Welcome to the lecture series of Basic Electrical Engineering. The subject code is ECE 101. Today in this video lecture we will discuss the topic RLC series response of AC circuit. So in this we are having the three components: resistance, inductance and capacitance are connected in series with each other as shown in this diagram, and a voltage, AC voltage, is given to the circuit. The voltage across the resistance is VR, the voltage across the inductance is VL, and the voltage across the capacitance is VC, and the current given to the circuit is I. So the things are written here. V is the applied voltage which is given to the circuit. I is the RMS value of the current. VR is the voltage across the resistance and it is given by IR and units are volts. Then VL is equals to voltage across inductance and it is given by I into XL and units are volts. VC is the voltage across capacitance IXL and units are volts. Now we know that XL is equals to omega L and it can be written as 2 pi FL, and XC is equals to 1 by omega C and it is 1 upon 2 pi FC. Now if we are talking about the phasor diagram, as in the previous lectures I have told you that what is the relationship between the current and voltage in case of RL network and in the case of RC network. Now here we see the combined result. Now we are taking one assumption in this case that VL, the voltage across the inductance, is greater than the voltage across the capacitance. Now look into the phasor diagram. On the x-axis we are having the current I, and we know that the voltage across the capacitor lags the current by 90 degree, and this is VR because the voltage in the resistance is in phase with the current, and the voltage in capacitor lags behind by 90 degree and voltage in the inductor is leading by 90 degree. So we are taking this condition, VL is greater than VC, so we put here VL minus VC, this will become VL minus VC, and we join these two lines points, this VL minus VC and VR. So this is our total voltage, this is our total voltage. This is how we draw the phasor diagram, as I have shown here clearly. On the x-axis we are having the current and voltage is in phase, voltage in the resistance is in phase with current, and voltage across the capacitor lags behind by 90 degree and voltage across the inductor is leading by 90 degree, and according to this assumption case X VL greater than VC, so we take this VC upside, it will become VL minus VC. So and we join these 2 points and we get the total voltage. Now from this phasor diagram we find out different various values. The first one is impedance. For impedance, from this triangle we know V square, this resultant voltage V is equals to VR square, voltage across the resistance, this, plus VL minus this VL minus VC square. Fine. Now we put the values of VR. VR is equals to IR square and VL is equals to IXL, and VC is equals to IXC. So from here we make it out, I comes out, and we take it on the left side, and we will left with this equation: V upon I is equals to under root R square plus XL minus XC square, and V upon I is equals to, as we know, V upon I is equals to Z. So Z is equals to R square plus XL minus XC the square, the whole under root, and we can put the value of XL and XC. It is written here. We get this formula, under root R square plus omega L minus 1 upon omega C the square, and omega we can replace by 2 pi f, so it will become R square plus 2 pi FL minus 1 upon 2 pi FC the square. So we got the three formulas from this. Then current, we know current is V upon Z, and Z, we find out the value of Z in the impedance. So we replace this Z with this formula: Z is equals to under root R square plus XL minus XC the square. Fine. So this is for the current, and we can put the value in the terms of omega, or we can put the value in the terms of 2 pi FL. So the third term is power factor. Power factor is cos phi. Here I draw the phasor diagram again, and we know cos phi is this angle, and this is base upon hypotenuse, and base is VR. This VR, this is base, and this is hypotenuse. So cos phi is base upon hypotenuse. VR upon V is equals to IR upon IZ. I cut down, and we will left with R upon Z. So cos phi is equals to R upon Z. Then sin phi. Sin phi is perpendicular upon hypotenuse. The perpendicular is this value. So VL minus VC upon V, we put the value. VL is equals to IXL minus IXC upon IZ. Fine. So when we simplify this, we will get sin phi is equals to XL minus XC upon Z. Then we find out the different powers. AC power, P is equals to VI cos phi. We put the value of I, and we put the value of RZ. So it will become V into I. We put take this Z here. It will become V upon Z into R. V upon Z is I. So I into here we are having one I into R. So it will become P is equals to IR square watts. The units are in watts. Fine. Then reactive power, it is given as Q is equals to VI sin phi, and we put the value of sin phi, and we will get this result, I square XL. This is the result which we got, I square XL minus XC. Fine. Then next one is apparent power. S is equals to VI, and I into Z into I. We put the value of V, and I square Z, and units are volts ampere. And the units of this reactive power, as I have told you, that VAR. Then representation of phasor diagram. The phasor diagram is represented in three ways: the polar form, rectangular form, and trigonometrical form. In polar form, we are having V is equals to Vm sine omega t plus theta. V is equals to R into angle, the theta angle. R is this resultant term, and angle theta. R is equals to Vm. If then angle theta is equals to means angle is equals to theta. If theta is positive, then we will get V is equals to R angle minus theta. In the rectangular form, we can put it as V, as we know V is equals to Vm sine omega t plus theta, and V is equals to x plus Iy, and or x minus jy. Then x is called Vm cos theta, and y is Vm sin theta. We put the value of x and y in the above equation. Into this equation, we will get V is equals to Vm cos theta plus Vm sin theta. If angle is negative, then it will become Vm cos theta minus Vm sin theta, this equation. Then in trigonometric form, we are having V is equals to Vm sine omega t plus theta. Here we take V is equals to Vm e j theta, or Em e raised to power j theta. If theta is negative, then we write it as V is equals to Vm e minus j theta. So this is all about the different formulas which are used for different phasor forms. We are having the three phasor forms: polar, rectangular, and trigonometrical. And in this lecture we talked about the RLC series response of AC circuit, where we discussed the phasor diagram. We find the impedance, we find the current, then power factor, then different powers: AC power, active power, reactive power, and apparent power. So this is all about today's lecture. Hope you like this lecture. Thank you very much.